The last video we discussed how to use an LED on a basic circuit and program it with Arduino code. Now this time we'll be discussing this component right here. This is a potentiometer, this three-legged component. And what this does, it's a variable resistor. So it works just like a resistor, just the only thing that differentiates from it is that it can change the different resistance values as you scroll the knob because of the wiper that it has over here. That it's able to change the different resistance levels and will allow you to limit current and increase current because the resistance values can increase and decrease at the same time on the potentiometer component we see here. Now to see this work, I'm going to use TinkerCAD in this case. So always use a resistor, and I always like to use what is this? 330 ohms. 3 ohms is a special number. And let's grab that is red. And then black for the negative. Connect that. Red. This, I know it's a terminal 1, terminal 2, but this should be the cathode and this should be the anode. Another wire. Connect this to the anode pin of the LED. This will allow for current to run from the potentiometer to the LED and make the current run. Now all that's left to do is connect this to our power source. See if I can get this straight. Alright, there you go. Black. That's not quite straight. There you go. And let's start running. Oh, I think I know why it's not working. Well, because we probably burnt out the potentiometer. So let's grab a resistor. There you go. Oh, that's why is it not working? God be kidding me. You have, oh, I know why it's not working. Every time I record a video, such a stupid thing has to happen. Because I'm using the wrong side of the terminals for this. This has to be down here. No kidding, of course it was not working. And so what this potentiometer is doing is limiting the current. So resistance value is dropping. And as the resistance value is dropping, more current resistance value is increasing, so less current is running through the LED, and that's why it just starts to get dim and it dies out. And the more you keep on increasing it, it will eventually explode. You're running the resistance value is dropping too much that eventually it will explode. And that's a very basic circuit that you'd use for a potentiometer to an LED, which is really cool. Now I'm going to try and figure out a way so that the LED doesn't blow up. Well, how would you do that? Well, we're going to use a resistor and connect to the potentiometer. Similar to how we did with the LED. We used a resistor. And that way, that'll prevent our LED to blow up. Just like so, connect it, start simulation. And it should not blow up on us. There you go. So we have a balance we have a proportionality in both sides. And that allows us to have a stable current and so our components don't fry out. So now we will be testing this with an Arduino, with TinkerCAD, to see exactly how much current is being lost, how much resistance is being increased, and how much resistance is being decreased. To do that, we'll use the Arduino IDE that's built in TinkerCAD. So for this part of the video, I have wired up my circuit. It may look a little different because I decided to use the breadboard to connect to the Arduino microcontroller separately. These two LEDs, or these two legs, or wires, are connected to ground because they're on the negative pin, and then this negative pin connects to the ground pin of the Arduino. So then the signal pins, like the positive terminal of the LED and the positive terminal potentiometer, they're connected to 5 volts. Actually, the LED is connected to its signal, which is 10. But the Arduino only works at 5 volts, so it's going to turn on this entire circuit. So that's the circuit right here. And then we have the negative. They have the wiper pin is connected to analog 2. Analog 2 are the digital pins that allow you to use in-between values. And that's exactly what we want. We want to read the in-between values. So when we turn this knob, we will see exactly how much voltage is being read and exactly how much resistance the potentiometer is increasing and decreasing. Because remember, for voltage to decrease, the scalar has to go high. There will be more voltage allowing in the circuit. But for resistance to increase, the scalar, you'd have to drop it down. So that way the voltage value will decrease and the LED won't turn on. But I have done a code that will allow me to say, okay, if the potentiometer, if its resistance exceeds 4 volts, the LED will turn on. And that's because we're using if statements. If statements will allow us to do that on the Arduino. So when we turn on the code, we'll see that the LED will turn on as a warning that, okay, the resistance of the potentiometer has reached 4 volts. So that's too much voltage. So that's another way to explain that with the Arduino code. And so we're using a 330 ohm resistor. I mean, I've always used 330 ohm resistors, and I've never had a problem with it. Circuits seem to work fine with that. So the code here, here's the code I made. And these are our various different integers. So pop in, that's what we use for the in-between values of analog 2. And now for read val is the value. So we put this on the serial monitor, and read val will tell us exactly the potentiometer voltage. And so since we're calling it, we're not going to give it a value. That's why we give it a semicolon. Now the float is a new command. Float is pretty much telling us, oh, the in-between values of the voltage. So it can tell us, it's not exactly 1 volt, so we're going to put it 0.9 volts or 0.8 volts. Those are the in-between values. And now the delay time, which is a quarter of a second, that's 250 milliseconds. And then our signal LED. What is the signal? Which it's pin 10. That's what we connected to the positive terminal of the LED to the Arduino with this wire to connect to the signal, which is on pin 10 of the Arduino. Now for a void setup, if you want to see exactly what the serial monitor is putting, we need to turn on the serial monitor. And the only way to turn on a serial monitor is if we put a serial.begin command. This 9600 is the baud rate that it's working with. So the standard baud rate is 9600. And now for pin mode I explained in the last video on what the pin mode procedure is. Pin mode sets up the values, the different values, either as an input or an output. In this case, for the pop pin, we're sending it as input because that's negative current going back, and pin mode LED red output for positive current. So, LEDs or the connections are going to go to positive direction, as we have to set it as output instead of input. And now for void loop, read val, we're setting equal to the analog read command. What is the analog read command? It reads the value from the specified analog pin, which means that the Arduino will map the input voltages as 0 to 5 volts into integer values between 0 to 1023. So that's what we were talking about this part. So the Arduino sets up integer values between 0 and 1023. But that basically means that it's the same thing as, the standard voltage reading values that we see now. 0 to 5 volts. 1023 means 5 volts. That's just the way the Arduino sets it up. And so we say down here, well, the V2 with the float in between values, that means we're going to convert the integer values of 1023 to the standard 5 volts reading values that we see in today's world. And in order to do that is using these periods. These periods are float values. If you don't use these periods, that means that, the Arduino is not going to be able to recognize it. So see, if we take these off, just leave it like, 5 over 1023. Because I know it's kind of confusing what this means. But 1023 is just the integer values. But we're going to convert that to voltage, standard voltage reading values, which is 1, 2, 3, 4, 5 volts. And so, off these periods, any in between values. So start simulations and see what happens. So we're setting this. Let's see. Nothing happens. So we have to use the periods in order for this to work. And then after that command, we go serial.print potentiometer voltages, and we're telling the Arduino that we're going to set up the serial monitor and we're going to print potentiometer voltages, and that's exactly what we see here. And you have to use these two symbols to be able to distinguish that that's what we're going to put on the serial monitor. And so we have to print this as a print line. What is a print line? Well, if you use a print line, that means that these will go in rows and rows and rows and rows. So it's going to tell you in an organized way that, potentiometer voltage is 1 or 2, 3, and so on. And so if we take a line off, just so you guys could better understand what I'm talking about, we do our print line off and we start our simulation. Hang on, I gotta put these periods back. Okay. We see that this happens. Well, because it's not on a print line, it's gonna constantly just print on the same side. Same exact side constantly. So we have to put a print line. It's gonna go one line here, one line there. And we have to use a print line. So LN. So we start simulation again. What happened here? Seems like my code has some errors. Oh, a serial N. That's not really, doesn't really make any sense. Okay. Stop code. Alright, I'll get to you guys when I fix this weird video here. Okay, so after fixing that issue, we see that when we set this thing to a print line, we see that we get this more organized. And now for these if statements. So this if statement is telling us that, if total voltage exceeds 4, then the digital right LED red, which is this LED, is going to turn on. In order to set it on, we have to set it high. And so that's the if statement I was talking about. And so when the total voltage is less than 4, that means that the LED will remain off. In order to do that, we have to set it as low. And decided to use this delay time because delay times it will allow us to see how this functions better. because if we don't use a delay, it's going to constantly repeat itself really quickly. We won't be able to notice the change. And so for that delay time, we decided to use it as a quarter of a second, so 250 milliseconds. And so if we turn this knob, we see the in-between values, and we see, oh, we've reached 1 volt. Now 2 volts, 3 volts, and then once it hits 4 volts, hang on. Oh, I had to put this at 10 volt. I don't know why I put that at 9. Start. And there you go. The LED turns on when it hits 4 volts. And then 5 volts. So that's the entire video. Basically, what we learned is that we can use if statements, and we can use the serial monitor to tell us, oh, exactly what's the resistance and voltage that's going on in this potentiometer. And this is proof that it's a variable resistor. So that's pretty much the end of this video. And like the video, subscribe, and I'll see you in the next one.